Do you know that this question has been appeared in CBSE exams, and it is the easiest 4 marks question if you know one smart trick. Let us solve it step by step using a powerful integral property that most students miss. We are supposed to integrate cos ax minus sin bx whole square between the limits minus pi to plus pi. We will use the property of integral, that is integral a to b of f of x dx is equal to integral a to b of f of a plus b minus x dx. Here a is minus pi and b is plus pi. Let us evaluate a plus b minus x. A plus b minus x is minus pi plus pi minus x, which is nothing but minus x. Hence, the required integral becomes I is equal to integral minus pi to pi of cos of a into minus x minus sin of b into minus x whole square. That is, a plus b minus x is nothing but minus x. Therefore, we have integral minus pi to pi of cos of ax minus sin bx whole square becomes cos of a into minus x minus sin into b minus x whole square dx. Now let us apply the trigonometric identities, that is cos of minus theta is plus cos theta and sin of minus theta is minus sin theta. Therefore, cos of minus ax becomes plus cos ax and sin of minus bx becomes minus sin bx. Therefore, I becomes integral minus pi to pi of cos ax, that is cos of a into minus x is nothing but cos ax, and minus of sin of b into minus x is nothing but plus sin bx, because sin of minus theta is minus sin theta and minus into minus is plus here. Therefore, sin of b into minus x is nothing but plus sin bx whole square. Let us proceed further. Now let us consider the given expression, that is the required integral, which was I is equal to integral minus pi to pi of cos ax minus sin bx whole square dx. Now it has been reduced to I as minus pi to pi of cos ax plus sin bx whole square dx. Let us take the average of these two equations, that is let us add these two equations and solve for I. Then I becomes 1 by 2 integral minus pi to pi of, when you add these two we get cos ax minus sin bx whole square plus cos ax plus sin bx whole square dx. Now let us consider cos ax minus sin bx whole square. Apply a minus b whole square formula. Then this reduces to cos square ax minus 2 cos ax sin bx plus sin square bx. And next consider cos ax plus sin bx whole square. Apply a plus b whole square formula. So we get cos ax plus sin bx whole square is equal to cos square ax plus 2 cos ax sin bx plus sin square bx. Now let us add these two equations. When you add left hand side, you get cos ax minus sin bx whole square plus cos ax plus sin bx whole square, which is equal to 2 cos square ax plus 2 sin square bx. That is cos square ax plus cos square ax is 2 cos square ax, and sin square bx plus sin square bx is 2 sin square bx, and minus 2 cos ax sin bx plus 2 cos ax sin bx is eliminated. Now the required integral becomes I is equal to 1 by 2 integral minus pi to pi of 2 cos square ax plus 2 sin square bx. That is, we are replacing cos ax minus sin bx whole square plus cos ax plus sin bx whole square by 2 cos square ax plus 2 sin square bx. Now when you take 2 common, it is eliminated because we have 1 by 2 outside the integral. So we are left with I is equal to minus pi to pi of cos square ax plus sin square bx into dx. So let us proceed. Cos square ax plus sin square bx. These are the two terms we are supposed to integrate now. Let us use the trigonometric identities. Cos square ax is nothing but 1 plus cos 2ax by 2. Sin square bx is nothing but 1 minus cos 2bx by 2. let us replace cos square ax and sin square bx. Therefore, I will be integral minus pi to pi of 1 plus cos 2ax by 2 plus 1 minus cos 2bx by 2. Upon simplification, we have 1 by 2 plus 1 by 2 is 1 here, and we have cos 2ax minus cos 2bx whole divided by 2. Let us proceed by integrating term by term. Integral 1 dx is integral 1 dx between minus pi to pi is x between minus pi to pi, and we have 1 by 2 outside here, and integral cos 2ax is sin 2ax divided by 2 between minus pi to pi, and minus cos 2bx we have, so we have minus 1 by 2 here, and integral cos 2bx is sin 2bx by 2b between minus pi to pi. So let us evaluate term by term. We have x between minus pi to pi. When you apply the limit, we have pi minus of minus pi, which is 2 pi, and when you simplify this, that is sin 2ax by 2a between minus pi to pi. Replace x by pi, so we have upper limit minus lower limit, so that is sin 2a pi by 2a minus sin of minus 2a pi by 2a. We know that sin 2n pi is 0. Therefore, we have sin 2a pi and sin of minus 2a pi both are 0. Therefore, second term becomes 0. Similarly, third term is also 0. The only difference is in the first term we have a, in the second term we have b. Therefore, sin 2bx by 2b between minus pi to pi is 0. Therefore, I becomes, the first term is 2 pi and the remaining two terms are zeros. Hence, the answer is 2 pi. If this method has helped you, give it a like and share it with your friends. For more scoring strategies in NCERT, CBSE, JEE and KCET maths, don't forget to subscribe to the channel. Let us master every concept one question at a time.